What if dark matter was actually a reality? It's one of the most baffling mysteries of our time. Scientists have proposed that a whopping 85% of the matter in the universe is invisible, undetectable except by its gravitational pull. They call this mysterious substance dark matter. And while it has never been observed directly, indirect evidence for its existence is abundant. In fact, some physicists argue that not only is dark matter real, but it also surrounds us. According to scientists, dark matter is a type of matter that is invisible and does not interact with baryonic matter, which is the type of matter that makes up everything we can see. Despite being invisible, dark matter is thought to make up a significant portion of the universe, approximately 80% of all matter. Gravitational lensing occurs when the gravity of a massive object distorts the light from objects located behind it. This distortion can create a magnified and distorted image of the background object. By studying the gravitational lensing of distant galaxies, scientists have observed that the amount of lensing is much stronger than expected based on the visible matter in the foreground galaxy. Here are a few reasons why the discovery of dark matter is important. This suggests that there is a large amount of invisible matter, dark matter, contributing to the gravitational field of the galaxy and causing the light distortion. The presence of dark matter in the early universe would have affected the way matter and energy distributed, which could have influenced the formation of galaxies and other large-scale structures. Dark matter interacts with gravity, like normal matter, but it does not interact with electromagnetic force. The search for dark matter has already led to the development of new technologies and instruments that can be used in other areas of research. The discovery itself would open up new avenues of research and technological advancements, pushing the boundaries of human knowledge and exploration. Studying its properties would help scientists better understand the nature of gravity and the fundamental forces of nature. Understanding the role of dark matter in the early universe would provide valuable insights into the evolution of the cosmos. What if dark matter was actually real? What if it's everywhere? Let's explore a few possibilities. While dark matter cannot be seen directly, its presence is inferred from its gravitational effects on visible matter and radiation. All these pieces of evidence have led to the current understanding that dark matter is a significant component of the universe. For example, it could lead to the development of new materials that exhibit unique properties due to the interaction between dark matter and light. Additionally, it could provide new insights into the nature of dark energy, another mysterious force that is believed to be accelerating the expansion of the universe. For example, scientists can observe the effects of dark matter on the rotation of galaxies. Some scientists speculate that the interaction between dark matter and living organisms could play a role in biological processes such as photosynthesis or cell signaling. By studying this interaction, researchers could gain a deeper understanding of the fundamental principles governing life itself. It would challenge our understanding of what is real and what is not, and it could raise questions about the nature of existence itself. It reminds us that there is still so much we do and know about the universe, and that there are still so many mysteries waiting to be solved. It's a reminder that we are only just beginning to scratch the surface of understanding the world around us. Despite ample evidence for its existence, it remains undetected, leading to numerous hypotheses and theories. What if dark matter wasn't just a scientific hypothesis, but an actual phenomenon occurring right now? If dark matter were real, it would drastically alter our comprehension of the universe. From its effects on galaxy rotation to gravitational lensing, we have indirect evidence of its existence. Experiments like Lux and Bread are searching for direct evidence of dark matter. The implications of discovering dark matter are immense, potentially revolutionizing physics and technology. It would also force us to reevaluate our place in the universe and our understanding of the laws that govern it. And don't forget to smash that like button and subscribe for more videos like this. Thanks for watching. Until next time. These particles would be difficult to detect as they would leave no trace in particle accelerators or other detection experiments. It could mean that the fabric of reality is much more complex than we currently understand. It could also suggest that there are other forms of matter and energy that we have yet to detect. Furthermore, the discovery of dark matter could revolutionize the field of particle physics and cosmology. It could also lead to the development of new technologies and sources of energy that we never imagined possible. In this scenario, dark matter would glow in the dark, so to speak. What if it was part of the very fabric of our reality? This idea might sound far-fetched, but it's not entirely out of the realm of possibility. In fact, some physicists have proposed that dark matter could exist as a kind of quantum foam that permeates the entire universe, even our own backyard. It would emit a faint glow that would be visible to the human eye. This glow would be particularly noticeable in regions of space where dark matter is concentrated, such as around galaxies and galaxy clusters. Telescopes would be able to map the distribution of dark matter by detecting the intensity and color of the glow. This would provide a direct visualization of the cosmic web, the vast network of dark matter filaments that permeate the universe. However, they would still have a gravitational pull that could be measured. In this scenario, dark matter would exist all around us, but we would not be able to see or interact with it in any way. It would be like an invisible cloud surrounding us. Galaxies rotate much faster than expected based on the amount of visible matter they contain. WIMPs would be more easily detectable than the hypothetical particles mentioned earlier, but they would still be challenging to spot. Various experiments are underway to detect WIMPs, and the discovery of such particles would provide strong evidence for the existence of dark matter. The Standard Model is the current theory that describes the fundamental particles and forces of nature. However, it does not account for several observations, including the unusual properties of dark matter. Therefore, the discovery of dark matter would indicate the need for a new theory that explains its properties and interactions. This suggests that there is an invisible mass within the galaxies that is providing additional gravity to keep the galaxies spinning at these high speeds. It's in the walls of our houses, the air we breathe, and the very ground we walk on. There may be dark matter all around us right now, and we just don't know it. So what if dark matter wasn't just an obscure scientific hypothesis? What if it was actually real? What if it's everywhere? Join us as we explore the mind-bending implications of dark matter existing right here, right now. What is dark matter? Before we can answer the question of what the world would be like if dark matter were real, we first need to understand what dark matter is. How do we know that it exists? As mentioned earlier, one of the most compelling evidence comes from the study of galactic rotations. When observing spiral galaxies, astronomers noticed that the stars in the outer regions of the galaxies were moving faster than expected. This observation cannot be explained by the visible matter in the galaxy, such as stars and gas. Therefore, scientists hypothesized that there must be an invisible mass, dark matter, contributing to the gravitational field of the galaxy and causing the stars to rotate faster. There are several pieces of evidence that support the existence of dark matter. Another piece of evidence for dark matter comes from gravitational lensing. In addition to these observations, scientists have also inferred the existence of dark matter from studies of the cosmic microwave background radiation and the large-scale structure of the universe. Why is it important? The discovery of dark matter would be a major breakthrough in our understanding of the universe. It would revolutionize our understanding of fundamental physics and cosmology. First, it would provide evidence for new physics beyond the Standard Model of particle physics. Second, it would help explain the formation and evolution of the universe. Third, it would advance our understanding of fundamental concepts, such as gravity and the nature of matter. Finally, it would inspire future research and technological advancements. What if it was real? While the exact nature and properties of dark matter remain unknown, scientists have put forward various hypotheses and models to explain its behavior. One possibility is that dark matter is composed of exotic particles that interact with normal matter only through gravity. Another possibility is that dark matter is made up of weakly interacting massive particles, WIMPs, which can interact with normal matter through a weak nuclear force in addition to gravity. What if it interacted with light? What if dark matter had a different interaction with light? What if it could absorb or emit light in a specific range of wavelengths? Not only would this discovery revolutionize our understanding of the universe, but it would also have significant implications for technology and life as we know it. Furthermore, the interaction between dark matter and light could also have profound implications for life as we know it. What if it was everywhere? What if dark matter wasn't just out in space, but actually everywhere? What if it was literally in our backyard? If dark matter was everywhere, it would have profound implications for our understanding of the universe. However, the implications of dark matter being everywhere go beyond just scientific discovery. It could also have profound philosophical implications. But the most exciting thing about the prospect of dark matter being everywhere is the sense of wonder and possibility it opens up. The bottom line, dark matter is one of the most perplexing mysteries of our time. What do you think? How would you feel if dark matter was confirmed to exist? Share your thoughts in the comments below.